Hi everyone, I'm Rishikesh C from Sri Venkateswara College of Engineering. Welcome back to my channel. Today let's discuss about big data analytics. Harnessing big data for climate and environmental monitoring. In an era of unpredicted environment challenges, the power of big data analytics has emerged as a transformative tool for climate and environmental monitoring. By leveraging advanced data collection, processing, and visualization techniques, scientists, polymaker, policymakers, and data analysts can gain unparalleled insights into the complexities of our planet's ecosystems, informing critical decisions that shape the future of our world. Satellite emerging and remote sensing, data acquisition, advanced satellite and aerial imaging technologies continuously gather vast amount of data on land use, vegetation, water bodies, and atmospheric conditions, providing a comprehensive view of our planet's dynamic element. Data processing. Sophisticated algorithms and machine learning models analyze the raw satellite and remote sensing data, extracting valuable insights and patterns that would be impossible to discern through manual observation, visualization, and interpretation. Data visualization tools transform complex environment data into easy to understand maps, graphs, and simulations, empowering decision making to make informed choice that safeguard our planet. Predictive modeling and early warning system. Forecasting climate pattern. Big data analytics enable the development of sophisticated climate models that can accurately predict long-term weather patterns, seasonal variations, and the frequency and intensity of extreme weather events, allowing for procreative planning and mitigation strategies. Monitoring environmental risks by leveraging real-time data from a vast network of sensors and monitoring stations. Big data analytics can detect early signs of environmental degradation such as deforestation, population, and habitual loss, enabling rapid response and intervention. Informing policy decisions. The insights gained from big data analytics provide critical intelligence for policymakers, empowering them to develop evidence-based strategies and regulations that addresses pressing environmental challenges from climate change to biodiversity conservation, precision agriculture, and sustainable land management, optimizing resource allocation, monitoring crop health, enhancing sustainability, improving food security, optimizing resource allocation by integrating data from soil sensors, weather stations, and satellite imagery. Big data analytics can help farmers precisely manage irrigation, fertilizer, and other inputs, boosting productivity while reducing environmental impact. Monitoring crop health. Advanced analytical techniques can detect early signs of plant stress, disease, or pests, enabling targeted interventions and minimizing the need for broad spectrum pesticide or other harmful practices. Enhancing sustainability. Big data driven insights can inform sustainable land management strategies such as crop rotation, soil conservation, and biodiversity preservation, ensuring the long term viability of agriculture ecosystem, improving food security by optimizing agriculture practice and mitigating environmental risk. Big data analytics can contribute to increased food production and distribution, helping to address the global changes of food insecurity. Monitoring biodiversity and ecosystem health, species tracking, big data analytics combined with sensors, network, and camera traps can help researchers and conservationists monitor the movements, behavior, and population trend of endangered species. Inform target conservation effort, habitat mapping, detailed spatial data obtained through satellite imagery and drone survey can be used to create high-resolution maps of critical habitats, allowing for the identification of fragmentation, deforestation, and other threats to biodiversity. Ecosystem modeling. Complex mathematical models and simulations powered by big data can help scientists understand the intricate relationship between different species and their environment, informing ecosystem management strategies. Early warning system. By integrating real-time data for various sources, big data analytics can provide early detection of emerging threats to ecosystems such as diseases, outbreak, invasive species, or environmental diseases, enabling rapid response and mitigation. Monitoring and mitigating population data collection in extensive sensors network, satellite imagery, and crowded sourced data collecting from effort provided as expensive view of air, water, and soil pollution levels across the globe. Data integration, big data platforms integrate and harmonize the divisor dataset, enabling the creation of detailed population maps and trends over time. Predictive modeling, advanced analyticals, and machine learning models can forecast the dispersion and impacts of populant, informing targeted interventions and policy decisions. Mitigation strategies, the insights derived from big data analytics can guide the development of effective population control measures, sustainable urban planning, and innovative clean technologies. Disaster preparedness and responsive early warning. Big data analytics can provide advanced warning of natural disasters such as hurricanes, floods, and wildfires by analyzing data from weather monitoring systems, satellite imagery, and predictive models. Situational awareness, real-time data from various sources, including social media and sensor networks, can help emergency response teams gain a comprehensive understanding of the evolving situation on the ground, enabling more effective and coordinated relief effort. Recovery and resilience. Big data analytics can support long-term disaster recovery and the development of essential infrastructure by identifying vulnerable areas, evaluating the impact of intervention, and informing risk mitigation strategies. Informed decision making. The insight gained from big data analytics can help policymakers and emerging planners make more informed decisions about resource allocation, evaluation planning, and the implementation of disaster essential technologies and practices. Citizen science and community engagement. Crowdsourcing data. Citizen science interventive leverage the power of community generated data collecting through mobile apps, wearable device, and other online platforms to supplement and enrich the dataset used in environmental monitoring and analysis. collaborative problem solving by emerging engaging local communities in the data collection and analysis process. Big data interventives can foster a greater sense of ownership and investment in environmental solution, leading to more effective and sustainable outcomes. The democratizing insights, user-friendly data visualization tools, and interactive dashboards empower citizen policymakers and community leaders to access the interpret environmental data, supporting informed decision making and collaborative action at the local level. Ethical consideration and data governance, data privacy and security as the use of big data is in environmental monitoring increases. It is crucial to establish robust data governance framework that protect individual and community privacy, ensure data security, and prevent the mis- misuse of sensitive information. Equitable access and representation. Big data initiative must prioritize inclusive data collection analysis, ensuring that the perspective and needs of diverse communities, especially marginalized groups, are adequately represented and addressed in environmental decision making. Transparency and accountability. uh, Effective data governance requires a high degree of transparency in the collection, processing, and application of environmental data with clear mechanism for public oversight and accountability to build trust and forecast collaboration. Responsible innovation as new technologies and analytical approaches emerge, it is essential to clarify, evaluate their potential benefits and risks, and to develop ethical guidelines that ensure the responsible and equitable use of big data in environmental monitoring and management. The future of big data in environmental monitoring. As the world grapples with the urgent challenges of climate change, environmental degradation, and resource scarcity, the role of big data analytics in environmental monitoring and management will only continue to grow. By leveraging the power of advanced data collection, processing, and visualization techniques, scientists, policymakers, and community leaders can gain unpredicted insights into the complex dynamics of our planet's ecosystem, informing critical decision that shapes a more sustainable and resilient future for all. Thank you.